Hello everyone, welcome back to my YouTube channel. This is Soumya S, currently studying in Sri Venkateswara College of Engineering, Bangalore. Today I am here to discuss about the topic as shown in the screen, Deterministic Finite Automata from the subject Automata Theory and Compiler Design. Introduction to Deterministic Finite Automata. A deterministic finite automata is a mathematical model used to recognize patterns in strings of symbols. It consists of a finite set of states, a set of input symbols, a transition function, a start state, and a set of accepting states. DFAs are widely used in computer science and linguistics for tasks such as lexical analysis and pattern matching. Definition of DFA. A DFA is defined as a phi tuple Q summation rho Q naught F, where Q is a finite set of states, summation is a finite set of input symbols also known as the alphabet. Rho is the transition function which maps a state and an input symbol to a new state. Q naught is the start state and F is a set of accepting states. Representation of DFA. DFAs can be represented graphically using state transition diagrams. Each state is represented by a node and transitions between states are represented by directed edges labeled with input symbols. The start state is indicated by an arrow pointing to it and accepting states are denoted by double circles. Working of DFA. The DFA starts in the start state and reads input symbols one by one. For each input symbol, the DFA transitions to a new state based on the current state and the input symbol. The transition function determines the next state based on the current state and input symbol. Deterministic versus non-deterministic. DFAs are deterministic, meaning that for each state and input symbol, there is exactly one next state. Non-deterministic finite automata allow multiple next states for a given state and input symbol. NFAs have more expressive power than DFAs, but are more complex to analyze and implement. Difference between deterministic algorithm and non-deterministic algorithm. Given a particular input, the computer will give always same output. In this case, the computer did not understand what is the actual output. Can solve the problem in polynomial time. Cannot solve the problem in the polynomial time. Can determine what is the next step. Cannot determine the what is next step. Language recognition using DFAs. DFAs can be used to recognize regular languages, which are languages that can be described using regular expressions. Regular languages are closed under union, concatenation, and clean star operations. By constructing a DFA for a given regular language, we can determine whether a given input string belongs to the language or not. Equivalence of DFAs and regular expressions. Every DFA can be converted into an equivalent regular expression. Conversely, every regular expression can be converted into an equivalent DFA. This equivalence allows us to switch between these two representations of regular languages. Theory of DFAs and REs. RE, concise way to describe a set of strings. DFA, machine to recognize whether a given string in a given set. Duality. For any DFA, there exists a regular expression to describe the same set of string. For any regular expression, there exists a DFA that recognizes the set. Minimizations of DFAs. DFAs can often be simplified by reducing the number of states while preserving the same language. Minimization of DFAs aims to find an equivalent DFA with the minimum number of states. Several algorithms such as the Hopcroft's algorithm and Morse algorithm exist to minimize of DFAs. Limitations of DFAs. DFAs are limited in their ability to recognize certain types of languages. They cannot recognize context-free languages, which require more powerful models such as push-down automata or context-free grammars. DFAs are only suitable for recognizing regular languages which have a simpler structure than context-free languages. NFA versus DFA. NFAs and DFAs recognize the same set of languages known as regular languages. DFAs are easier to implement. Applications of DFAs. DFAs have various practical applications, including lexical analysis in compilers and programming languages, pattern matching in text processing and search algorithms, network packet filtering and firewall rule matching, finite state machines in digital circuit design and control systems, natural language processing for tasks like tokenization and morphalization analysis. These are the applications of DFAs: lexical analyzer, syntax analyzer, semantic analyzer, intermediate code generator, code optimizer, and code generator. DFA optimization techniques. Several techniques can be applied to optimize DFAs for better performance and memory usage. State minimization to remove redundant states, transition compression to reduce the number of transitions, transition table compression to save memory, input symbol encoding to reduce the size of the alphabet, transition table indexing for faster lookup operations. 5 applied optimization methods are evolutionary operation, simplex method, Lagrangian method, search method, and canonical method. DFA limitations in real-world applications. Despite their usefulness, DFAs have some limitations in real-world applications. They can become complex and hard to maintain for large language recognition tasks. Handling non-regular languages requires more sophisticated models. DFA-based applications may require significant computational resources for complex patterns or large input sets. Designing efficient and optimal DFAs for certain tasks can be challenging. DFA tools and libraries. Several tools and libraries are available to work with DFAs, such as JFLAP, JFLab, a software package for experimenting with formal languages, automata theory, and related topics. Python libraries like PySimple Automata and Automata Lab. Online DFA simulators and visualizers for educational purpose. Compiler constructions tools like Lex and Flex, which use DFAs for lexical analysis. Conclusion. Deterministic finite automata are valuable mathematical models for recognizing patterns in strings. They are essential in various fields, including computer science, linguistics, and network security. DFAs offer simplicity, determinism, and efficiency of recognizing regular languages. By this, I'll end my session. Thank you.